there is a condition for event H to be happen where event E has to be occurred already. The calculating the probability of an event F when E is already happened is nothing but conditional probability. When I say F has to be calculated when E is already happened, we say F over E. So these are the events where when you throw a die, their face show up the same numbers. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to introduce the new chapter, probability. So in our first PUC classes, you have learned how to calculate the probability for an event. And in this session, we are going to learn a conditional probability. So what is this conditional probability? So when I take a random experiment of a coin tossing 3 times or 3 coins tossed at a time. So the sample space of this experiment will be S, H, 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 that is 3 heads, 2 heads, 1 tail in the form HTT, HTH, THH, and 2 tails at a time, that is TTH, THT or HTT, and all the 3 are tails. So these are the sample space we will get. So that is, we can have 3 heads, 2 heads combination, 2 tails combination, or all the 3 coins or tails. Now when I say this is a random experiment, since we have more than one outcomes here, so suppose I'll take 2 events. Let me take E, where event E is the 2 heads coming up. So at least 2 heads coming up. Then it must be H, 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 T, H, T, H, and T, H, H. So let F be the event where 1 tail appears. So 1 tail appear means what we can get here? T, H, H, or we can have H, T, H, 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 T. So these are the combination where we can have only 1 tail. So now when I say that this is the sample space of the experiment, I need 2 events E and F, where event E is at least 2 heads should be there, and event F is we should have 1 tail. Now when I say here, clearly you can see here we have a common element in E and F. So that means in event E also THH has to appear, and event F also THH has to appear. So that means to happen event F, event E should has to be already happened, or to happen event E, F should has already been happened. Only then we can get event E, or only then we can get event F. So that means there is a condition for event H to be happen where event E has to be occurred already, because they can't occur simultaneously since they share same outcome here. So therefore, that is to occur event F, there is a condition that event E has to be already happened. So calculating the value of, or the calculating the probability of an event F when E is already happened is nothing but conditional probability. Or calculating event E when F is already happened, it is called as conditional probability of E over F. So that is why we use conditional probability. Since 2 events cannot occur simultaneously here, that is, since they share some outcomes, therefore what has to be here to happen one event, there is a condition that one event or the other event has to be already happened. Then only we can have event E or event F. So thus the definition of condition probability lies like that. If E and F are 2 events associated with the sample space of a random experiment, the conditional probability of the event E given that F is already occurred is given as PE over F is given by. So the formula which we use is P of E over F. It is the condition of probability of E where F is already happened is given by probability of intersection of two events divided by probability of F. Remember, probability of cannot be equal to 0. That is, the value of probability of F cannot be equal to 0. That means there should be at least one outcome in common with event E. Similarly, calculating the probability of an event F when E is already happened or E is already occurred, that is also given by probability of intersection of two events divided by probability of E, provided here also probability of E cannot be equal to 0. So this is the formula to find out the conditional probability. So when we say E has to be calculated where F is already occurred, it is denoted by E over F. When I say F has to be calculated when E is already happened, we say F over E. And here the formula differs. For E over F, it is P of E intersection F by P of F. And for P of F over E, we have E intersection F divided by P of E, provided the denominator cannot be equal to 0. Now let us see some of the properties of conditional probability. Let E and F be the events of the sample space S of an experiment. Then we have probability of S. S always denote the sample space. S over F or probability of F over F is equal to 1. So probability of any event is given by P of E intersection F divided by P of F form. So when I say P of S intersection F here, so we can clearly see it is S intersection F divided by P of F. So what is intersection of any event with the sample space? It is F only. So we have P of F over P of F cancels, hence the value is 1. So therefore we can say probability of sample space over event is always 1. Now P of F over F means it is again P of F intersection F divided by P of F here. So intersecting with the same event or same set, you will result with the same set. So probability of F by probability of F, when you cancel, it is equal to 1. Now the second one is, if A and B are any two events of a sample space and F is an event such that P of F not equal to 0, then condition probability of A union B over F is given by, we know the total probability or the sum of two probability A union B can be written as P of A plus P of B minus P of A intersection B. Hence, if F is the conditional probability we have where P of F is not equal to 0, we write it as P of A union B over F as P of A over F plus P of B over F minus P of A intersection B over F. Next, we know that condition probability of the complement event or E dash is always P of E dash over F is equal to 1 minus P of E over F. We know that P of E dash is 1 minus P of E. So for conditional, just write over F on both sides. Next, here we have a question. If P of A is equal to 7 by 13, P of B is equal to 9 by 13 and P of A intersection B is equal to 4 by 13, evaluate P of A over B. We know that here P of A over B can be written in the form of P of A intersection B divided by P of B. So that is P of A conditional B. Now probability of A intersection B is given, that is 4 by 13. B is also given, that is 9 by 13. When you cancel it, the value is equal to 4 by 9. Next one, if probability of A is 0.6, probability of B is 0.3 and probability of A intersection B is 0.2, find probability of A over B. Clearly, probability of A over B can be written as probability of A intersection B divided by probability of B. A intersection B we have 0.2 and probability of B we have 0.3. So we can also write it as 2 by 3. Next one, if probability of A is 0.8 and probability of B over A is 0.4, then find P of A intersection B. So probability of B over A is given as 0.4 and probability of B over A can be written as A intersection B. We can also write it as B intersection A divided by probability of A is equal to 0.4. Now we need to find out probability of A intersection B is equal to 0.4 into when P of A goes there, whose value is given there, 0.8, 0.32. Next one. A family has two children. What is the probability that both the children are boys, given that at least one of them is a boy? So when I say a family has two children, what is the probability that both the children are boys? So let me take E as both the children are boys, okay? And F, I will take it as at least one of them is a boy. We know the sample space. If two children we have, we can take as boy, 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 girl, or girl, boy, girl, girl in an order. So when I say both of them are boys, so we have B, B. Given that at least one of them is a boy, then we have B, 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 G, G, B. So this is the chance. Now we need to calculate the probability of E over F. So that is both are boys if at least any one of them are boys in the second event. So how it is given? Again here P of E intersection F divided by P of F. So what is E intersection F here? We have E as well as F. Intersection of F is only boys, boys. That is E intersection F is equal to only one element or one outcome. Hence, the probability of E over F will be 1 by 4. E intersection F is 1. Probability of E intersection is 1 over sample space. That is 1 divided by 4. And probability of F is, we have 3 outcomes. Probability value is 3 over total outcome. So that is 3 by 4. Hence 4 get cancelled. The value is 1 by 3. Next one. A die is thrown 3 times. Events A and B are defined as below. A 4 on the third row. B 6 on the first and 5 on the second row. Find the probability of A given that B has already happened. So we need to calculate probability of A over B. So for that we need what is set A, set B as well as A intersection B. Now A is given there, that is 4 on the third row. So what are the possibilities we can have 4 on the third row? That is 114, 124 etc. until 164. Similarly we can have 214, 224 etc. 264. Then we can have 314, 324 until 364. Next we can have 414, 424, 434, 454, 464. Next again from 514 to 564 we can have. Again here from 614 to 664 we can have. So a die is thrown 3 times means the sample space n is equal to 216. So n is equal to 216 is the total outcomes. Now for this event here, so number of A, so that is number of A is equal to 36 outcomes we have. So therefore what can I write the probability of A? Probability of A is 36 divided by 216. Now let's take the event B. 6 on the first and 5 on the second row. So let's see, for set B we can have 6, 5, 1, 6, 5, 2 until 6, 5, 6. That is only 6 outcomes are possible. 651, 652, 653, 654, 656 are possible. So that means we have only 6 outcomes for probability of B is here now 6 divided by 216. Because the total number of outcomes is 216. Hence the probability of B is 6 over 216. Now, which is the element which is common in both? So, we have here 614 means we have here in this row 654. So, the only common element, that is A intersection B, is 6, 5, 4. So, therefore, probability of A intersection B will be 1 divided by 216. Hence, probability of A over B, that is occurring of event A where B has already happened, can be taken as probability of A intersection B divided by probability of B, that is 1 over 216 divided by 6 over 216. Hence, the value is 1 divided by 6. So, clearly observe the question. 4 on the third row means you have to see the third row must be on 4 only. So, we will get total 36 outcomes according to the total outcomes 216. Hence, probability is 36 by 216. Second one, they say first one should be 6, second one should be 5. So, therefore, only 6 elements we can get. The common element is only 654. Hence, for the formula P of A over B, we will get the value as 1 by 6. Next. Mother, father and son line up at random of a family picture. E is the event where son should be on one end. F is the event where father is in the middle. Determine E over F. Now here, so first let us write the sample space, how they can stand for the picture. So if I take son, father, mother. So mother, father, son, or mother, son, father. Next, I can take son, mother, father, or son, father, mother. Next, I can take father, son, mother, or father, mother, son. So, these are the poses for picture they can give according to the line. Now, event E is that sun should be on one end, either at the first or at the last. So, what is the possibility? Sun should be at the end, MFS or SMF or SFM or FMS. So, these are the possibilities of an event E. Next, event F says father in the middle. So, the father in the middle means there is only two possibilities, MFS or SFM. Now, clearly see which is common, E intersection F. E intersection F is F, MFS and SFM. Now, what is the probability here? Clearly, you see probability of E is 4 by 6. So, that is, it is equal to 2 by 3. Probability of event F is 2 by 6, 1 by 3. Probability of event E intersection F is also 2 by 6, that is equal to 1 by 3. Now, what we need to calculate? Probability of E over F. So, that is probability of E over F is probability of E intersection F divided by P of F, that is equal to 1 by 3, 1 by 3 cancels, whose value is 1. Remember, the maximum value of the probability you can get is 1. Next, assume that each born child is equally likely to be a boy or a girl. If a family has 2 children, what is the conditional probability that both are girls, given that the youngest is a girl, second, at least one is a girl. So, we need to consider already the condition that both are girls here. So, for condition both are girls, first we need to calculate the condition of happening of the event. Both are girls when given that the event of choosing the youngest is a girl is already happened. So, let me take this as A. So, if A is both are girls, then the only possibilities for both are girls is G. Because we know the sample space here, we can have 2 boys. So, B or BG or GB or GG. This is the only possibilities. Elder one, younger one. So, it may be boys, girls or girls, boys. Combination, that is 4 now. So, here hence I can choose as event A is equal to both are girls means, so G, G. The first condition here, they say, let me take an event E. Event E is the youngest is a girl. So what are the possibilities? So the youngest is a girl, that is B, G and G, G. Now I need to calculate what is the probability of both are girls when the youngest is a girl. So clearly you can see here A intersection E is here G, G. So therefore probability of A over E is probability of A intersection E divided by probability of E. So A intersection means we have only one outcome out of 4 outcomes. So 1 by 4 divided by 2 by 4. So we can get value as 1 by 2. The next one says when both are girls. So second one, the condition is at least one is a girl. So at least one is a girl means I'll take the event as if I have 3 conditions B, G, G, G and GB. So therefore probability of A over F is probability of A intersection F over probability of F. A intersection F means again we have one outcome as common. So 1 by 4. Probability of F is 3 over F because the total probability is 4. So the value is equal to 1 by 3. Next one, given that two numbers appearing on throwing 2 dice are different, find the probability of the event. The sum of numbers on the dice is 4. So the first event is when you throw a die, so the numbers appearing on the face of the 2 dice must be different. So they cannot be same. We know that 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5 and 6, 6. So these are the events where when you throw a die, their face show up the same numbers. But here the events of 2 dice showing the numbers must be different. So that means, so here I can remove all the doublets here. So I can get only 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, I can get 2, 1 except 2, 2 I can write 2, 3 like this. I can write the total number of events here will be, because the total n is equal to 36. I am removing these 6 elements. So 36 minus 6 is equal to 30. That means number of elements in the event E is 30, where the dice shows different number. The second event is, let me take it as if, it is saying that when a die is thrown, the sum of the numbers on the dice must be 4. So 4 means the possibilities are 3, 1, 1, 3 and 2, 2. So these are the possibilities. Now here, so what is E intersection F? E intersection F means, remember E has a pair where both numbers are different. So therefore the only common elements can be 1, 3 and 3, 1. Now we need to calculate that the probability of an event where the sum of number is 4, where the dice when you throw, it shows a different number is already happened. That is, we need to calculate probability of F over E. So that means here we need to calculate probability of E intersection over probability of E. How many elements in E intersection? We have only 2 elements. But what is total number of elements? We have n is equal to 36. So therefore it is 2 over 36 divided by, what is E? Number of elements in E is 30. That is 30 divided by 36. 36 cancel. 2 ones are 2 15s are. Hence the value is 1 over 15. Next, an instructor has a question bank consisting of 300 easy true or false question, 200 difficult true or false question, 500 easy multiple choice question and 400 difficult multiple choice question. If a question is selected at random from the question bank, what is the probability that it will be an easy question given that it is a multiple choice question? So we need to calculate how many easy questions are there and how many total multiple choice questions are there. So when I say we need to calculate easy question as to be a multiple choice question, so let me take P of E intersection F. So how many questions are easy and multiple choice question? So we have 500 easy multiple choice question. So easy and multiple choice means it is E intersection F we can take. So how many questions are there in total? So we have 300 true or false, 200 true or false, 500 multiple choice which is easy and 400 multiple choice which is difficult. So 300 plus 200, 500, 500 plus 500, 1000, 1000 plus 400, 1400 question. So therefore the total probability, that is N, is 1400. Hence, when we calculating probability of easy multiple choice question, it is 500 divided by 1400. Now what I need to calculate? I need to find the probability of easy question, and also it should be a multiple choice question. How many multiple choice questions are there? So let me take it as probability of F. So total multiple choice questions is 500 easy plus 400 difficult divided by overall question is 1400, that is 900 divided by 1400. Thus here when I am calculating probability of E over F, we have probability of E intersection F divided by P of F. So E intersection F is 500 divided by 1400. Probability of F is here, total multiple choice question is 900 and probability is 900 over 1400. 1400 cancels, 0, 0, 0, 0 cancel. Hence the value of the probability is 5 over 9. So this is how we are going to calculate the conditional probability of one event when the other event is already happened. So we already take the happened event as a sample space for the second event. That is why we will get the value of the conditional probability in the denominator, where the total probability values or outcomes will be equal to F. So hence this is how we will calculate the conditional probability. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.